Yo, what up, everybody? Today I'm coming at you with a video about force schemas and free body diagrams. Both are important tools in analyzing the forces that are on an object. A force schema looks something like this, and a free body diagram looks something like this, all right? And we're going to go over both of them, talk about what they mean, and show you step by step how to create a force schema and how to create a free body diagram. So please stay with us till the end. What forces are affecting this box? Well, notice we're only going to talk about the box. All right, so there's several different things, but we're only going to look at the forces that are acting on the box itself. And so we're just going to kind of go through and think about what's happening to the box. So one, if it's on Earth, then there's a force of gravity directed straight towards the center of Earth. Right? And gravity, there's gravity anywhere in the universe, so we always know there's going to be a force of gravity. And notice I write down the type of force, but I also write down what is causing the force and what is receiving the force. So from the Earth to the box, and that's going to be important when we do the force schema. Secondly, I notice the box is being lifted up by a rope, right? And so there's a force of tension, and that force of tension comes from the rope to the box. Now, I know what you might be thinking. You might be thinking, well, isn't he pulling up on the rope, so isn't he causing the force? And the answer is yes, he is causing the force by pulling up on it, but we're only looking at the box and the things that are directly applying a push or pull on the box. And so the box itself, if you can imagine, if the box could feel, it would feel a rope pulling up on it. It wouldn't feel his hand. All right, so we're just going to do the rope. If we did the rope and his hand, then we would be doubling up and saying that there's two forces when there's really only one force that's pulling up in the box here. That's not the only force, not the only force is, because if you notice, the box is not sinking into the ground, right? And he's not pulling hard enough to for the box to just hang there. So the floor is still supporting some of the box's weight. And so there's a normal force from the floor to the box, right? Or from the ground to the box, as we say, same difference. And so those are the three forces. Okay, there's no forces left or right because it's a flat surface, so friction's not happening at this point. So we have three forces, and we have the objects here that are causing it. I'm just going to circle those. Okay, these are the things involved. And when we create a force schema, we're going to look at the things that are involved in it. And those things are the earth, the rope, and the ground. So basically, I just circled the nouns. These things are either causing a force, either receiving a force. Right? And so I put those things in these little ovals. I have the box, I have the rope, the ground, the earth. And these all have arrows because each of these objects is giving a force to the box. However, these are not the only forces present because if you've heard of Newton's third law, you know that every action has an equal and opposite reaction. So for each of these forces, we expect there to be another force, which we call a force pair, right? And so we add these forces right here. And so everywhere where there's a force towards a box, there's also a force in the opposite direction. And so what are these force pairs? If we had to label what they are, what are they? Well, you take these sentences that we have here, and you're just going to rewrite them, but you're going to flip the two nouns at the end. Instead of the force of gravity from the earth to the box, it's now from the box to the earth. Instead of tension from the rope to the box, it's now tension from the box to the rope. Normal force from the ground to the box is now box to the ground. All right, so all of these forces exist, and we know they do by Newton's third law. And so we're going to draw arrows to and from the box. There should never be in a force schema a arrow that does not have another arrow in the equal and opposite direction. All right, if you see that, that means you're missing a force. So that's where a force schema becomes important, just to keep keep us from missing a force when we're analyzing a situation. Okay, so from the force schema, we're now going to go to a free body diagram. A free body diagram is where we look at just the forces that are acting on the box, and we draw arrows in the direction of those forces. And so notice there's 3 forces that are being applied to the box itself. And so we draw the box here, and for each of these forces, we're going to draw an arrow. And at this point, we have to make some decisions about how big these forces are. And so we know that there's a force of gravity, and that's pulling it down. We know that there's a tension force, and he was pulling up on it, so that was pulling the box up. The ground is obviously going to push up on the box to keep it from falling through. Now, we don't know from this problem how big each of these are, because we're not told how hard he's pulling up on it, but we do know that these two put together need to balance out the force of gravity. And the reason we know that, show the picture again, is because this box is not accelerating upwards or downwards. It's just staying there. And so that means that the forces on top have to equal the forces on the bottom. Okay, and so that's the information that we get from a force schema and a free body diagram. We'll probably do some more examples with these later, and hope to see you all in another video.